Today we are walking through the paper titled GDPO Group Reward-Decoupled Normalization Policy Optimization for Multi-Reward ARL Optimization.
Give me the big picture first.
This paper studies how to train a language model with several rewards at once, such as correctness, format, or response length, without letting those signals blur together. The main claim is that better reward handling makes optimization more stable and more aligned with what users actually want.
What gap in earlier work is the paper trying to close?
The gap is in the common GDPO recipe for multi-reward training. It adds all reward components first and then normalizes the combined score, so different trade-offs between objectives can end up looking identical to the optimizer.
Why is that collapse such a problem during training?
Because a response that is strong on correctness but weak on format can be treated the same as a different response with the opposite trade-off. Once those cases collapse into one advantage value, the update no longer knows which objective should move up or down.
So what does GDPO do differently?
GDPO normalizes each reward separately inside the rollout group, then adds those normalized advantages after each objective has kept its own contrast. After that, it applies one more batch-wise normalization so the final scale stays stable during training.
And how do they handle different priorities between rewards?
The paper also studies preference priority. It shows that changing reward weights is useful, but when one objective is much easier than another, the better fix can be to condition the easy reward on the hard one. Let us put the first key equation on the board.
What should I read first in this equation?
Equation 5 says the final training signal is still a single advantage, but it is built by adding objective-specific advantages instead of mixing the raw rewards up front. So GDPO keeps one update direction while preserving which reward created each distinction. The next equation shows the second normalization step.
Why is this extra normalization worth keeping?
Equation 6 scales that summed advantage across the batch. The point is not to change which response is better, but to keep the magnitude well-behaved as the number of rewards grows. And the appendix shows that this step helps avoid unstable runs. Now let us switch from formulas to the method overview.
Which part of this design matters most?
At the top, GDPO forms one combined reward and normalizes once. This next diagram makes the collapse problem concrete with a tiny example.
What should I pay attention to first here?
On the left, GDPO compresses several reward combinations into only 2 advantage groups. On the right, GDPO keeps 3 groups, so different reward trade-offs stay distinguishable during the update. The paper then scales that intuition up.
Does removing the standard deviation term solve the same problem?
Not really. Removing the standard deviation term helps only a little. As the number of rollouts or reward dimensions grows, GDPO still keeps far more distinct groups than either GDPO baseline. Now let us move to task results.
What stands out most in these training curves?
On tool calling, GDPO reaches strong format scores earlier and keeps correctness higher through training. So the gain is not only a cleaner theory result. The method also converges faster and gives a better balance between following constraints and solving the task.
And is that pattern limited to tool calling?
No, the paper reports the same overall direction in math reasoning and coding reasoning too. Across different reward formulations, reward weights, and model settings, GDPO gives a better trade-off between task sets inside constraints such as length, format, or bug-free code.
What is the clearest takeaway at the end?
The clearest takeaway is that multi-reward ARL breaks if different objectives are mashed together too early. GDPO keeps those objectives separate long enough to preserve their signal, then recombines them in a stable way, and that design translates into better results across the paper's 3 evaluation domains.
So the win is not just higher scores.
That wraps up this paper walkthrough.